Hello all, we're starting Unit 5B where we're going to be talking about linear functions, and this lesson is just an introduction to this word function. Your learning targets today is I know that a function is a rule with exactly one output for each allowable input, and I know that if a rule has exactly one output for each allowable input, then the output depends on the input. All of this will make more sense once we dig in, I promise. So a function works kind of like a machine. It's a special rule or equation where inputs are put into the machine one at a time, and then whatever rule you have inside of the machine performs its operation on that input and then determines each output. So you can see this as our delightful function machine right here. Just a nice little box, and we're putting something in and it goes inside that machine and the rule happens and it spits something unique out, and we call that our output. So this can be an equation or just a general rule. Like we have a rule here that says whatever you input, we will write 1 if our input is odd and write a 0 if the input is even. So here we have ourselves a nice little list of inputs, and what happens is first a -3 goes into our function machine, and because the rule is write 1 if the input is odd and a 0 if it's even, that means that our output is a 1. Same thing, our -2 goes into the machine, and what comes out is a 0. -1 goes in, what comes out is a 1, 0. It's neither odd or even, so I would just say leave that one open. But then we got ourselves another 1, we got ourselves another 0, and another 1. That is an example of a function. It can really be that easy. The definition of a function is that functions are special kinds of rules that assign exactly one output to each allowable input. And in your notes, what I would do is I would be underlining that and drawing arrows to that exactly one output for every input. And we'll say things like, well, the output is a function of the input, or that output depends on the input. What this means is that whatever is coming out of this function machine is completely reliant on this thing that went in, because for everything that comes in, one unique thing will come out. And we have seen a function this year. Back in Unit 3, we looked at the equation y equals kx to describe proportional relationships. And we could give our k that constant proportionality of value, and let's just change this to say, how about this is y is equal to 2x. What we have here is a function, and our actual function inside the machine, what we would write is just that 2x portion. And then we have our inputs and we have our outputs. And I could make a little list, give myself some inputs, aka give myself some x values, and start plugging them into this function machine. So I could put a 0 in, and what I would get out is it would go into that function machine, and 2 times 0 is 0. So this would give me an output of 0. Same, I could plug a 1 into that function machine. 2 times 1 is 2, so it would spit out a 2. Plug a 2 into the function machine, and what comes out is a 4. Now, no matter what number we put into this machine, aka no matter what our input is, we're going to get one unique output. So we would say in this case that our y value is a function of our x value. Let me write that down. I would make sure that goes in your notes as well. All right, let's take a look at another example. Here's another rule. This rule is our y is equal to 5x minus 7. And we have this little function machine. I'm going to go ahead and draw it. And the function machine says that some number goes in, is multiplied by 5, and then has 7 subtracted from it. Okay, let's pick some values to test and find out, is y a function of x? Meaning, will our output depend on what we put into this machine? All right, let's test some values for x, or some inputs. Let's input 0. What would happen there is 5 times 0 minus 7 is 0 minus 7, so that would be spitting out a -7. Okay, if we put in a 1, we've got ourselves a 5 times 1 minus 7 becomes 5 minus 7. We get ourselves a -2. There's one unique output for that input. There's nothing that could happen to put a 1 into our machine and get any number out other than -2. And lastly, let's try a 3. We put a 3 in. What happens is that 3 is multiplied by 5 and then has 7 subtracted from it. So we have a 15 minus 7, and what we get is an 8. So our output is an 8. And I'm actually going to color code these. Here's an input and its corresponding output. An input and its corresponding output. An input and its corresponding output. So again, with all of these numbers, there's nothing, you couldn't throw a 3 in there and get any other number than an 8. You couldn't throw a 0 in there and get any other number than a -7. And on and on and on. Therefore, we would say that y is a function of x, meaning that what number comes out does depend on what number goes in. All right, let's check out a different kind of example. So in general, there's a relationship between the age and height of a human. Between the ages of birth and 18 years old, humans typically grow in height as they get older. So what we have in this graph is the ages and heights of a group of humans. And we are being asked, is height a function of age? In other words, is a person's height dependent on their age? Could we use age as a predictor of height? Could we use height as a predictor of age? And so we have this graph. We have our x and our y coordinates. Our x is all of our inputs, and our y is all of our outputs. And let's just start looking. Let's see what happens. If we input 17, we have one person here who is 17 years old, there is only one output. This output is that this 17-year-old is 53 inches, okay? Let's check out a 15-year-old. So this 15-year-old, same thing. You input the age 15, and what comes out is 50, okay? What about a 13-year-old? You input the age 13, and all of a sudden, you get two different outputs. We have a 13-year-old right here who is 46 inches, and another 13-year-old who is 48 inches. So automatically, if we have an input with two outputs, that means it's not a function. And that happens a couple times here. That happens for 15-year-olds. No, it doesn't. I'm sorry. For 16-year-olds, there's 1 and 2 outputs. For 14-year-olds, there's 1 and 2 outputs. So we have 3 different inputs here that have multiple outputs, and therefore it is not a function. You would say that height is not a function of age. And to be more specific, we could say that height is not a function of age because there are multiple potential heights, aka there are multiple outputs for every person's age, or aka for every input there are multiple outputs. That is the definition of a function. Huzzah! All right, here's a you try it. So you are told that you will have to wait for 5 hours in a line with a group of other people. Determine if 1, you know the number of minutes you'll have to wait, and 2, you know how many people will have to wait. If the answer is yes, if this is something you can determine, that means it's a function, and I want you to draw an input-output diagram. So again, that's just as simple as a box with a rule inside of it, and then an input and an output. And write a statement that describes the way one quantity depends on another. If your answer is no, give an example of 2 outputs that are possible for the same input. All right, go ahead and pause, give this a try, come on back, see how you did. So for the first one, I say yes, because we know how many minutes are in an hour. And so we know that the number of minutes you wait is a function of how many hours you wait. And you'd pop an input of 5. Your rule would be to multiply that by 60. And your output would be how many minutes you waited. And for the second one, that answer is no. There could be 1 person or there could be 1,000 people. We don't really know. So it's not a function. Okay, I'm sure this is a little confusing. I know it's brand new. I put a couple of should do's on Canvas that you could try if you wanted a little more practice, or just go ahead and try your journal problems and let me know how I can support you. All right, you guys are awesome. Thank you.